So today we are going to do network delay time. So you're given a network of n nodes labeled from 1 to n. You're also given times. A list of traverse time as directed edges. Okay, time I is ui, vi, where ui is the source node, vi is the target node. Wait is the time that it takes for a signal to travel from source to target. So we will send a signal from a given node k given the minimum time. Okay, return the minimum time it takes for all the nodes to receive the signal. If it is impossible for all n nodes to receive the signal, return -1. Okay. Quickly go through the examples. Input are the edges. From the edges, we got the graph 2, 1, 2, 3, 3, 4. 4 nodes, and k is 2. That means we send the signal from 2, and we wanted to see what's the minimum time for every node. Obviously, this one is 2. Reach here will take 1. Reach here will take 1. Reach here will take 2. So minimum time is we will at least need to take time 2. And then, okay, that's pretty straightforward. Since time takes won't be a minus number, and we wanted to find the minimum time from one node to all the other nodes, I would reach out to Digistral for this problem. So for Digistral, that's for this algorithm, I'm going to first. So the general idea is that we always start from the closest node from the starting point, and we add the node as visited, and then we update the unvisited node with the distance to the start, and ultimately we get and ultimately after we go through this digestral, we go through the node to see which node is still unvisited. If that node is still unvisited, that means okay, this is not possible to reach all the node. And they are all visited, we find the largest number in the distance from the start, because that's the minimum time takes. We need to satisfy the longest node from the starting signal place, right? So things are pretty straightforward. I can start coding up. Okay, since it is one-based indexing, we wanted to get the minimum distance, right? So we initialize it with the max number for now. Let me check the syntax for max number representation in Python. Cool. I'm going to use a heap to do the digest rule. What I need to do is I will definitely, since in the later part we are always going to find the one that is closest to the node. So got 0 here as the comparing value. And the node itself is k. Use k to denote the node itself. Also, we need to find a convenient way to represent the graph rather than using the edges. Okay, now we start the digest rule. By using digest rule, we got the weight, the node. Wait. I actually think there's could be some problems with the syntax, but I'll do this later. I'm not going to check the syntax file now. First, we finish this implementation. Okay. Okay, concentrate. Okay, we got this weight node. Awesome. And then we just mark this as visited. The way we mark this as visited is we flip the visited node. As true. So once we edit this, we try to say, is there anything we wanted to update for the neighbors? Oh, and also, it is possible that what is added into the heap is now stewed. We check what is the new distance from the neighbor node to the original node. It would be actually, I don't think it's a good idea to call this here, to call this weight, as distance is the more accurate part. Because in the heap, we are always comparing closest node from the start position. Now the new distance becomes the weight plus That's this. And if the new distance is smaller than this, and also the neighbor is not visited. We would like to update it. Don't forget to update to the heap queue with the neighbor and distance and the neighbor itself. Okay, after everything, we go through the mean distance. You just check what is the minimum time. if this is okay, we wanted to find the largest there. Okay, if someone is still infinite, that means this is impossible. Just return -1. Else we're comparing this with the result. Now we return result. I believe I should get a heap and then push it there. But I forgot the syntax. Into us syntax. Okay, so I got to know the syntax for initialize a heap. We have this. Oh, now we need to initialize the graph. Instead of edges, this should be times. syntax still not that good though. What are the problems? Okay, I think I have a gap in the APIs of heap. And also, we need to analyze the space and time complexity. Since first we need to go through every edges, that will take O of E to create the graph. Let me analyze the time complexity. And also for digestral, for every node, it is at most going to be popped up once. So that would be O of A space O of A here. And each pop will take log B. It's B log B. As the max size of the heap is B. And for push, most there will be E times push. So it will be E log B. The space complex, so ultimately the time complexity is E log B. The space complexity, let's see, the graph need to get all the edges and visited, and mean distance go to O log B, O of B. The heap is O of E. So it's V plus E.